This is an example of conditional probability that we're doing. We're going to use the data table below from the 100 senators from the 108th Congress of the United States. Of the males in the study, there were 46 male Republicans, 39 male Democrats, and 1 independent male, for a total of 86 males in the study. In the females, there were 5 Republican females, 9 Democrat females, and 0 independent females, for a total of 14 senators that were female. And of the Republicans in total, there were 51 Republicans, 48 Democrats, and 1 independent, for a total of 100 senators in the study. In Part A, we're asked, if we randomly select one senator, what is the probability of getting a Republican given that a male was selected? Well, in this example, we're going to use our formula. We're going to find the probability that a Republican was selected given a male. So using the formula, we find the probability of a Republican and a male and divide it by the given information that we had selected a male. So the probability of a male. Well, we look in the table and we see of the Republicans and being male, there are 46 Republican males out of 100. That's how we end up with 46 over 100. The probability of males in the study, there are a total of 86 males over the grand total of 100 people. So simplifying that down, we get 0.535 or 53.5% that were Republican given a male was selected. In Part B, if we randomly select one senator, what's the probability of getting a male given that a Republican was selected? And we want to see, is the same result found in exercise Part A that we just got? Well, using our formula, we're going to find the probability of a male given a Republican. We find the probability of both a male and a Republican and divide it by the given information that we have a Republican selected. So again, we have male Republicans, 46 out of 100. So there's 46 over 100 that meet those both criteria. The probability of being Republican is 51 over 100. And simplifying down, we get 0.902 or 90.2%, which is clearly not the same as Part A, so no, it is not the same result. In Part C, if we randomly select one senator, what's the probability of getting a female given that an independent was selected? So again, using our formula for a given information, a conditional probability, we're finding a female given independent. So both conditions, female and independent, we have 0 out of 100. And the probability of being independent, there is a total of 1 out of 100, which simplifies to 0 or 0%. In this last question, if we randomly select one senator, what's the probability of getting a Democrat or independent given that a male was selected? So again, extending our formula, we now have the probability of Democrat or independent given a male. The probability of dependent or Democrat or independent and male, we see we have to separate that out. So being a Democrat and a male, there are 39 out of 100. The probability of being independent and male is 1 out of 100. So we add those probabilities together. And then we're going to divide by the probability of male, which there are a total of 86 over 100. So simplifying down, we get 0.465 or 46.5%.